Hi everyone, today's video is going to cover the last major topic for Chapter 5. What we're going to be doing is writing the equations for parallel and perpendicular lines. So you've probably heard of these types of lines before, so the intro here might be review. Remember that parallel lines are lines that look like this. I'm just going to sketch an example. Okay, and so our definition of parallel lines are lines that do not intersect. So they could go on and on forever and ever, and they would never run into each other. The important piece to know here is that the slopes of parallel lines are always the same. So if I have two lines that are parallel, their slopes are the same. Now, perpendicular lines, on the other hand, might look like this. Okay, and I'm using this symbol here. This means that's a right angle or a 90-degree angle. And so perpendicular lines are lines that intersect. They do cross, but they cross in a very specific way. They intersect or cross at a 90-degree or a right angle. So lines that intersect at a right angle. This case, for slopes of perpendicular lines, those are opposite reciprocals. And hopefully reciprocal should be a very familiar word, right? Reciprocal is just when we kind of flip the fraction. So for example, slopes of perpendicular lines might look like this. One slope might be 2/3. And the other slope might be, or would be, -3/2. Those would be perpendicular because we flipped the fraction and it's also opposite sign. I could have a slope that's -4, and then my opposite reciprocal would be 1/4. So it has to be reciprocal and the two slopes have to be opposite signs. So part of the work we're doing today is determining if a pair of lines or certain lines are parallel, perpendicular, or neither. So that's what we're going to look at in this first example. Now, one thing to be aware of, so you can see in this example, I'm given the equations of three lines. Now, we said here the key to this is in looking at their slopes. So what we need to do is before we compare slopes, we need to make sure that all three lines are in slope-intercept form. So I'm going to make a note that we first have to have, all equations need to be in slope-intercept form. We can't compare the slope unless they're in slope-intercept form. Then once it's in slope-intercept form, we can easily compare the slopes. So let's take a look at our examples. Number 1 isn't in slope-intercept form, although it's pretty close here. The only thing I need to do is divide everything by 3. So let's do that. And I'm going to put it right next door here. I'm going to divide everything by 3. So I'm going to get y equals -5/3 x, and then I have plus 2/3. So there's my equation for line 1. Line 2 is already in slope-intercept form. Now, line 3, we have to do a little bit of work here. So I'm going to use this space down here. Let me move the paper up. And so let's get this in slope-intercept form. So I'm going to copy this down. 6x minus 10y equals 4. And we need to get that y by itself. So first I'm going to move over this 6x. So I have -10y equals, I'm going to write the -6x first, and then I have a +4. I'm going to divide by -10, and so I get y by itself. Now, 6/10, let's see if we can reduce that. I know we can, but let's go ahead and do that. So I have -6/-10. gives me a positive 3/5. And then let's go ahead and reduce this as well. I have 4 over negative 10, and I get negative 2/5. So 3/5 x minus 2/5. So remember, the key here is to look at their slopes. That's what we're focused on when we're determining if they're parallel or perpendicular. So for line 1, my slope is negative 5/3. For line 2, I have a slope of negative 5/3. And for line 3, I have a slope of a positive 3/5. So let's see what it asks. It says for each pair of lines, determine whether they're parallel, perpendicular, or neither. So let's look at line 1 and 2. Well, line 1, we said the slope was negative 5/3. Line 2 is negative 5/3 also. Since those are the same, those lines are parallel. I'm going to make a note here that they have the same slope. How about line 1 and 3? So line 1 is a negative 5/3. Line 3 is 3/5. So I notice that fraction has been flipped, so it is reciprocal. They also have opposite signs, so those are opposite reciprocal, which means those lines are perpendicular. I'm going to say slopes are opposite reciprocals. Did I fit? Let me move this over. Okay, then for 2 and 3. Again, I have line 2 is a slope of negative 5/3. Line 3 is 3/5. So those are going to be perpendicular. Again, because they're opposite reciprocals. Okay, go ahead and flip the page. Now, here's a slightly different example. And so we're going to have to be a little bit careful here as something a little bit funny happens. Now, this line, y equals 3/2, I know I don't have an x here. Since I see y equals, hopefully we should recognize that that's a horizontal line. And I know that horizontal lines have a slope of 0. Okay, let's look at the next one. Now, my variable's not by itself here, so I'm going to do some quick division. I'm going to divide by negative 3, so I get x is negative 2/3. Now, since I have x equals, this is my vux, right? So this is a vertical line. I know that slope is undefined. See if I can focus this a little better. Sorry about that. All right, and then last off here, I have x equals 3/2. Again, this is a vertical line. Okay, and the slope is undefined. So, it says for each pair of lines, again, determine whether parallel, perpendicular, or neither. So line 1 and 2. Now, we can't really use our opposite reciprocal here, but what I do know is that any horizontal line, I know a horizontal line is going to look like this. Any horizontal line and any vertical line, those are always going to be perpendicular. So if I'm comparing a horizontal line and a vertical line, those will always be perpendicular. So again, when I compare 1 and 3, I have a horizontal line and a vertical line. Those are going to be perpendicular as well. Now, 2 and 3, those are both vertical lines. They both have an undefined slope or the same slope, so those will be parallel. Okay, so at this point, this next example is very much like the first problem that we did. So I want you to go ahead and pause and try this one out. And then when you unpause it, you can compare your answer with what I've worked out here. Okay, so this one threw a little bit of a twist into things that hopefully you picked up on. When I solved, or when I put line 1 in slope-intercept form, I got a slope of -3. Line 2 and 3 are already in slope-intercept form, so for line 2 I have a slope of 3, and line 3 is a slope of -3. So now, when I'm comparing line 1 and 2, I notice that those two slopes, so -3 and 3, they're opposites, but they're not reciprocal. So those lines are not parallel because the slopes aren't the same. They're not perpendicular because I don't have that reciprocal piece, so that would be neither for 1 and 2. For lines 1 and 3, I notice they have the same slope, so those are parallel. And then 2 and 3, I'm back to the situation where they're opposites, but they're not reciprocal. So those would be neither as well. Okay, so the first piece of this has just been, if I have an equation, can I decide if they're parallel, perpendicular, or neither? And so for the last few examples here, what we're going to be doing is writing equations of lines that are either perpendicular or parallel to a given line. So let's look at this next piece. It says we're finding slopes of lines parallel and perpendicular to a given line. So it says consider the line 7x minus 5y equals -9. We need to answer what the slope of a line perpendicular to this line would be and what a slope of a line parallel to this line would be. So we know by now that if I'm comparing slopes, I first have to have the equation in slope-intercept form. So that's the first thing we're going to do, is rewrite this equation. So I have 7x minus 5y equals -9. My first step is going to be to move over the 7x. When I do that, I have a -5y. And on the right hand, I have a -7x minus 9. Now I'm going to divide by -5. And so I get y equals, now I can't reduce this, but negative over negative will give me a positive. So 7/5 x, and then plus 9/5. So I know the equation of my line is 7/5. So now, if I wanted to know the slope of a line perpendicular to this line, I have to take the opposite reciprocal of this slope. So the slope of my new line would be -5/7. On the other hand, if I want a slope of a line parallel to this line, I know parallel means the same slope. So the slope of my new line would also have a slope of 7/5. All right, let's see. Here's a very similar problem. Again, if you'd like to try it on your own, you can go ahead and pause. Otherwise, I will walk through this one as well. Okay, so consider the line 2x plus 9y equals 9. Again, we have the same questions. We need to know what the slope of a line parallel and perpendicular to this line would be. So our first step is to get the y by itself. And I'm going to run through that quickly. You can pause if needed. Okay, hopefully I didn't make any mistakes there. So now my slope is -2/9. So the slope of a line parallel to this line would be -2/9. And then if I want perpendicular, again, that's opposite. Reciprocal means my slope, since this slope is negative, mine's going to be positive. Reciprocal means to flip it, and my, excuse me, my slope is 9/2. All right, one last type of problem. Now we're going to write equations of lines that are parallel and perpendicular. So it's going to be using this piece we just did here with identifying the slopes, and then using the point they give us to actually write the equation. Now, since these problems just say to find the equation, they don't specify, we're just going to leave the equation in point-slope form. They don't specify that we need to put it in slope-intercept form, so we're just going to leave it in point-slope form. So in the interest of time, I'll do one where I talk through it, and then the next one will just give you the solution to check. So here we go. The nice thing about this problem is that it's already in slope-intercept form. So I know my slope is -5. So for part A, I'm going to write down here because I have a little more room. It says find the equation of the line that is parallel to this line and passes through this point. Now, parallel tells me it's the same slope, so I know slope is -5. And my point is 7, 2. And again, thinking back to a couple videos ago, if I have a point here and a slope, I'm going to put it in point-slope form, which is y minus y1 equals m times x minus x1. And again, this is my x1, y1. So my equation is going to be y minus 2 equals -5 times x minus 7. And again, since it didn't tell us we had to put it in slope-intercept form, I'm just going to leave that in point-slope form. Now, in part B, the only difference here is I need the line that's perpendicular. So now my slope, instead of being -5, I need it to be positive, and I need to flip it. So my slope is 1 over 5. My point is still 7, 2. So now if I use point-slope form, I have y minus 2 equals 1/5 times x minus 7. So that's all there is to this piece. So again, if you'd like to pause the video and try the next question, when you unpause it, you can check your work with mine. Okay, so here's the solution to the last problem. Again, if you have any questions, of course, feel free to ask. And otherwise, go ahead and try the homework.